Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Exception Handling Part 3, Handling Exceptions in Python, Try Except Statement with Practical Implementation, for the Class 12 students of Computer Science. So, let's dive in and get started. Let's discuss about handling exceptions in Python. What is exception handling? Exception handling is vital for preventing program crashes. It involves writing code to handle each exception, providing appropriate messages or instructions to the user. Need for exceptional handling. Exception handling is a widely employed technique across various programming languages, including Python, C++, Java, and Ruby. It aids in capturing and managing runtime errors to prevent program crashes, enhancing program reliability and user experience. Let's see the key points regarding exceptions and their handling, that is the need for exception handling. Python categorizes exceptions for specific handling. Exception handlers isolate error detection and correction from main program logic. Errors are tracked by the compiler or interpreter to locate their exact position. Exception handling applies to both user-defined and built-in exceptions. Let's learn about the process of handling exception. Exception object creation. When an error occurs, Python creates an object known as the exception object. This object holds details about the error, including its type, file name, and the position in the program where it occurred. Handover to runtime system. The exception object is then passed to the runtime system. The runtime system looks for appropriate code to handle the specific exception. Throwing an exception. This process of creating the exception object and passing it to the runtime system is termed as throwing an exception. Control transfer. Upon encountering an exception, control shifts to an exception handler. This interrupts the execution of the remaining program statements. Search for exception handler. The runtime system scans the entire program for an exception handler. Initially looks in the method where the error occurred. If not found, it traverses up the call stack to find a suitable handler. Call stack. The sequence of methods being executed is called the call stack. The runtime system searches this call stack in reverse order to locate an exception handler. Catching the exception. When a suitable handler is found, it's executed by the runtime process. This action of executing the appropriate handler is termed as catching the exception. End of program execution. If no suitable exception handler is found after searching the entire call stack, program execution halts. Now, you can see the flowchart describing the exception handling process. First, an error is encountered in a method. Exception object is created. Exception is raised. This is throwing an exception. Then runtime system searches for exception handler in the current method. If found, it executes the code, that is, catching an exception. If not found, it searches for methods in call stack in reverse sequence. Finally, if not found, program terminates. That is the end of program execution. These are the steps of handling exception. Let's discuss about the catching exceptions. Catching exceptions. An exception is considered caught when code designed to handle it is executed. Exceptions are captured within a try block and managed in an except block. Implementation. Suspicious code prone to exceptions is enclosed within a try block. Each try block is followed by an except block where exception handling code is written. Execution flow. If an exception occurs during execution of the try block, further execution halts. Control shifts to the corresponding except block to manage the exception. You can use the try except statement to gracefully handle exceptions. Here are the different methods for handling exceptions in Python. Method 1. Try and except block. Method 2. Try except with else block. Method 3. Try with multiple except blocks. Method 4. Try, except with finally block. Method 1. Try and except block. Purpose of try and except block. Used in Python to catch and handle exceptions during program execution. Try block execution. Code within the try block is executed normally as part of the program. Handling exceptions. Code following the except statement responds to any exceptions raised in the preceding try block. Defending against exceptions. Suspicious code that may raise an exception is enclosed within a try block to defend the program against errors. Execution flow. If an error occurs within the try block, execution is transferred to the corresponding except block. This prevents program termination and allows for controlled handling of errors. Here, you can see the format. The try except block runs specified code and executes alternate code if an exception occurs. The syntax of try except statement is, try : you do your operations here, except : if there is an exception, then execute this block. Let's see an example. Look at the yellow box for the Python code addition of two numbers, exception handling with try and except block. Line 1. This line is a comment indicating the purpose of the code block, which is to perform addition. Line 2. This line initiates a try block, indicating that the following code will be attempted, and any errors that occur will be caught by the except block. Line 3 and 4. These lines initialize two variables, n1 with the value 50 and n2 with the value 60. Line 5. Here, we have a printing statement which tries to print the sum of n1 and n3. However, there's a mistake. First is the syntax error. The print statement is incorrectly formatted. In this case, it should be print, sum of two numbers equals n1 plus n2, instead of n1 plus n3. And also we have the logical error. n3 is not defined anywhere in the code. It should be n2 to match the variable initialized earlier. Line 6. This line starts the except block, which handles any errors that occur within the try block. Line 7. This line prints a message indicating an error. However, it should be noted that it's inside the except block, meaning it will only execute if an error occurs in the try block. So the corrected code should be in line 5. Print sum of two numbers equals n1 plus n2. Now look at the output. Look at the red box. An error has occurred, indicates that an error occurred during the execution of the code, triggering the except block to be executed. When an exception occurs within the try block, Python jumps to the except block to handle the exception. In the except block, the code simply prints the message an error has occurred. Let's see another example, exception handling with try except block. Now, look at the yellow box for the Python code dividing two numbers. Line 1. This is a comment indicating the purpose of the code block, which is to perform division. Line 2. This line initializes a variable n1 with the value 0. Line 3. This initiates a while loop that will continue executing the following block of code as long as the value of n1 is not equal to 100. Line 4. This line initiates a try block. The code inside the try block will be executed, and if any errors occur, they will be handled in the except block. Line 5. This line prompts the user to enter a value for the dividend n1 using the input function. The eval function is then used to evaluate the user input as a Python expression. Let me explain the eval function used here. In this line of code, the input function prompts the user to enter a value for the dividend. Whatever the user enters will be treated as a string. For example, if the user enters 50, it will be a string, not an integer. Then, the eval function takes this string input and evaluates it as a Python expression. If the user enters 50, eval 50 will evaluate to the integer 50. Similarly, if the user enters 10 multiplied by 5, eval of 10 multiplied by 5 will evaluate to 50. Line 6. This line prompts the user to enter a value for the divisor, n2, using the input function, similar to the previous line. Line 7. This line calculates the quotient of the division operation between n1, dividend, and n2, divisor, using the floor division operator, and assigns the result to n3. The floor division operator in Python is used to perform division where the result is rounded down to the nearest whole number, integer, towards negative infinity. It divides the left operand by the right operand and returns the largest integer less than or equal to the quotient. Line 8. This line prints the calculated quotient to the console. Line 9. This initiates an except block, which catches any exceptions that occur within the try block. Line 10. This line prints a message indicating that an error has occurred if any exception is raised within the try block. Now let's see the output. The user is prompted to enter the dividend, and they input 50. Then, the user is prompted to enter the divisor, and they input 5. The code calculates the quotient of 50 divided by 5, which is 10. It prints the message the quotient is equals 10. Next, the user is prompted to enter the dividend, but they input ABC, which is not a valid numeric input. The code attempts to evaluate ABC using eval function, which raises a name error because ABC is not a defined variable or valid expression. The except block catches the exception raised by the invalid input, and it prints the message an error has occurred. Next, the user is prompted to enter the dividend, and they input 10. Then, the user is prompted to enter the divisor, and they input 0. The code attempts to calculate the quotient of 10 divided by 0, but division by 0 is undefined in mathematics and leads to a zero division error. The except block catches the zero division error raised by the division by 0, and it prints the message an error has occurred. Next, the user is prompted to enter the dividend again because the loop continues until the dividend n1 becomes equal to 100. Since the code snippet provided does not include any code to break out of the loop or terminate the program, it continues prompting the user for input. Note: when we use try except clause in the script and an error is encountered, a try block code execution is stopped and transferred down to the except block. Let's see the second method. Try except with else block. An optional else clause can accompany the try except block. If no exception is raised in the try block, the code in the else block is executed. The except block is executed only if an exception occurs within the try block. The else block allows for specific actions when no exceptions are encountered. Here, you can see the format. The try block runs specified code, the except block executes if an exception occurs, and the else block runs if no exception is encountered. The syntax of try except with else block is try : you do your operations here, except : if there is an exception, then execute this block. Else : if there is no exception, then execute this block. The code in else block is executed only if there is no exception. Let's see an example exception handling using try, except, else block. As you saw earlier, in syntax errors topic, when syntactically correct code runs into an error, Python will throw an exception error. This exception error will crash the program if it is unhandled. The except block determines how your program responds to exceptions. Now, look at the yellow box. This Python code is meant to illustrate how to handle exceptions when dividing two numbers. Now, look at line 1. This is a comment indicating the purpose of the code block, which is to perform division. Line 2 initializes the variable n1 with a value of 0. Line 3. This initiates a while loop that continues until n1 becomes equal to 100. Line 4. Try : the code inside the try block is executed. If an error occurs during this execution, it is caught by one of the except blocks. Line 5. It prompts the user to enter the dividend, the number to be divided. Line 6. It prompts the user to enter the divisor, the number by which to divide. Line 7. It performs integer division of n1 by n2 and assigns the result to n3. Line 8. It prints the result of the division. Line 9. If a name error occurs, typically when eval cannot evaluate the user's input, it prints an error has occurred. Line 10. If a zero division error occurs, when attempting to divide by 0, it prints division by 0 not defined. Line 11. If a syntax error occurs, typically when the user's input is not a valid Python expression, it prints syntax error. Line 12. If a type error occurs, when the data types of operands are inappropriate for the operation, it prints data types do not match. Line 13. Else colon. This block is executed if no exceptions occur within the try block. Line 14. It prints execution is normal. Done after successful execution of the try block. Now, let's see the output. The user enters 10 as the dividend and 2 as the divisor. Since 10 divided by 2 equals 5, the quotient is correctly calculated and printed. Since there are no exceptions raised during the execution of the try block, the else block is executed, printing execution is normal. Done. Next, the user enters 8 as the dividend and 0 as the divisor, leading to a division by 0 error. The code catches the 0 division error exception and prints division by 0 not defined. Next, the user enters XYZ, which cannot be evaluated as a number, leading to a name error exception. The code catches the name error exception and prints an error has occurred. Next, the user enters 10 plus, which is not a valid expression, leading to a syntax error exception. The code catches the syntax error exception and prints syntax error. Next, the user enters strings hello and world as the dividend and divisor respectively, which are not compatible for division. This results in a type error exception. The code catches the type error exception and prints data types do not match. Next, the user enters 100 as the dividend and 2 as the divisor. The quotient is correctly calculated as 50. Since there are no exceptions raised during the execution of the try block, the else block is executed, printing execution is normal. Done. Let's discuss about method 3. Try with multiple except blocks. The try statement can include multiple except blocks with specific exception names. Each except block handles a particular exception. Exception names can be specified after the except keyword to catch specific errors. Try with multiple except block. At the occurrence of an exception, the script follows these steps. Control is directed to the corresponding except block for the specific exception encountered. If the exception isn't specified in any except block, control goes to the except block without any exception name. If neither case is met, and there's no except block, the script terminates abruptly, akin to not using a try statement. In this structure, try with multiple except blocks, the code within each except block is executed based on the specific exception encountered, and if none match, the code following the except without an exception name is executed. The syntax of try with multiple except blocks is try colon, you do your operations here, except exception, name, 1 colon, if there is exception 1, then execute this block. Except exception, name, 2 colon, if there is exception 2, then execute this block. Except exception, name, 3 colon, if there is exception 3, then execute this block. Except colon, if there is no exceptions with the specified name given above, then execute this block. The code in except block, without any name, is executed only if there is no exception. Let's see an example. Look at the yellow box. Line 1. This is a comment indicating the purpose of the code block, which is to perform division. Line 2. It initializes a variable n1 and assigns it the value 0. Line 3. It initiates a while loop that continues until the value of n1 is not equal to 100. Line 4. Try colon. It begins a try block, indicating that this portion of the code may raise exceptions, and it needs to be handled. Line 5. It prompts the user to input a value for the dividend, converts the input into a Python expression, and evaluates it. The result is assigned to the variable n1. Line 6. It prompts the user to input a value for the divisor, converts the input into a Python expression, and evaluates it. The result is assigned to the variable n2. Line 7. It calculates the integer division of n1 by n2 and assigns the result to the variable n3. Line 8. It prints the calculated quotient. Line 9. It catches a name error exception, which occurs if a variable is referenced before it is assigned a value, and prints a corresponding error message. Line 10. It catches a zero division error exception, which occurs if the user attempts to divide by 0, and prints a corresponding error message. Line 11. This except block catches any other exceptions that may occur during the execution of the try block. It prints out the message an error has occurred. The code essentially repeatedly prompts the user to enter a dividend and a divisor until the dividend becomes 100. It then performs the division operation, handling potential errors such as invalid input or division by 0 gracefully. So, multiple except blocks are used to handle different types of exceptions separately, allowing for targeted error messages and graceful error handling without program termination. Let's look at the output. The program prompts the user to input the dividend. The user inputs 80. The program prompts the user to input the divisor. The user inputs 2. The program calculates the quotient by dividing the dividend, 80, by the divisor, 2, resulting in 40. It then prints out the quotient is equals 40. Next, the user inputs ABC, which is not a valid numerical value. Variable not present. Since the user input cannot be evaluated as a numerical value, a name error occurs, and the program catches this error, printing out variable not present. Next, the program prompts the user for the dividend again. The user inputs 50. The program prompts the user for the divisor. This time, the user inputs 0. Since dividing by 0 is undefined and results in a zero division error, the program catches this error and prints out division by 0 not defined. Next, the user inputs 10 plus, which is not a valid numerical value. An error has occurred. Since the input 10 plus cannot be evaluated as a numerical value, the program catches the error, generic except, block, and prints out an error has occurred. Next, the program prompts the user for the dividend once more. The user inputs 100. The program prompts for the divisor. This time, the user inputs 10. The program calculates the quotient by dividing the dividend, 100, by the divisor, 10, resulting in 10. It then prints out the quotient is equals 10. The program repeatedly asks the user for dividends and divisors, performing division operations and handling various types of errors, such as invalid input or division by 0, as the user provides input. Let's learn about the method for try, except with finally block. The finally block is termed as a cleanup or termination clause. It executes regardless of whether an exception occurred in the try block or not. Python allows implementing cleanup actions after executing code using the finally clause. In this structure, try except with finally block, the code within the try block runs, the except block executes if there's an exception, the else block runs if no exception occurs, and the finally block always executes. The syntax of try except with finally block is try : you do your operations here, except exception 1 : if there is an exception 1, then execute this block. Except exception 2: if there is an exception 2, then execute this block. And goes on, else: if there is no exception, then execute this block. Finally, always executed. The code in finally block is always executed, no matter what. Let's see an example. Line 1. This is a comment indicating the purpose of the code block, which is to perform division. Line 2. It initializes a variable n1 and assigns it the value 0. Line 3. It initiates a while loop that continues until the value of n1 is not equal to 100. Line 4. Try: it begins a try block, indicating that this portion of the code may raise exceptions, and it needs to be handled. Line 5. It prompts the user to input a value for the dividend, converts the input into a Python expression, and evaluates it. The result is assigned to the variable n1. Line 6. It prompts the user to input a value for the divisor, converts the input into a Python expression, and evaluates it. The result is assigned to the variable n2. Line 7. It calculates the integer division of n1 by n2 and assigns the result to the variable n3. Line 8. It prints the calculated quotient. Line 9. It catches a name error exception, which occurs if a variable is referenced before it is assigned a value, and prints a corresponding error message. Line 10. It catches a zero division error exception, which occurs if the user attempts to divide by 0, and prints a corresponding error message. Line 11. It catches a syntax error exception, which occurs if there is a syntax error in the user input, for example, an invalid Python expression, and prints a corresponding error message. Line 12. Executes this block of code regardless of whether an exception was raised or not. In this case, it simply prints done after the try-except blocks are executed. Let's see the output. The user inputs the dividend as 40. Then, the user is prompted to enter the divisor, 5. The quotient, which is 40 divided by 5, resulting in 8, is printed. Finally, done is printed to indicate the completion of this iteration. Next, the user inputs a non-numeric value, ABC, for the dividend. This causes a name error because ABC is not defined as a variable. The program catches this error and prints variable not present. Done is printed to indicate the completion of this iteration. Next, the user inputs the dividend as 30. Then, the user is prompted to enter the divisor. The user inputs 0 as the divisor. This causes a zero division error because division by 0 is not defined. The program catches this error and prints division by 0 not defined. Done is printed to indicate the completion of this iteration. Next, the user inputs 20 plus for the dividend. This input is syntactically incorrect because it's not a valid expression. This causes a syntax error. The program catches this error and prints syntax error. Done is printed to indicate the completion of this iteration. Next, the user inputs the dividend as 100. Then, the user is prompted to enter the divisor. The user inputs 2 as the divisor. The quotient, which is 100 divided by 2, resulting in 50, is printed. Finally, done is printed to indicate the completion of this iteration. In this program, the print statement given in the finally clause is always executed irrespective of whether exception occurs or not. So done gets displayed after every iteration of while loop. The finally block and a try-except statement ensures execution of specified code regardless of whether an exception is raised, serving as a mechanism for cleanup or finalization tasks. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Share this video with your friends and relatives. Watch the upcoming videos. You can check the link in the description box given below.